Hi. This video will demonstrate how to write an augmented matrix from a system of equations. It will also show you how to write a system of equations from an augmented matrix. So the first thing we're going to look at is we have a system of equations here. And I want to write this as a matrix. You want to make sure that all your x's are lined up, all your y's are lined up, and all your z's are lined up. You want to make sure that you've isolated your constant on the right hand side of the equal sign. So if you've done that, got all your variables on the left hand side and all your constants on the right, and you've lined up your x's, y's, and z's, you can simply generate the matrix by reading off the coefficients. The number in front of the x would be a 1, a -2, and a 7. That's my column, my x values, in other words, my x coefficients. My next column is going to be my y coefficients. In this case, I have a 2, a 1, and a 1. My third column is going to be my z coefficients, -1, -2, -1. And we call this an augmented matrix because I'm going to draw a straight line, straight down, and write my right hand side, or my constants, which is 2, -3, and 7. So when you see the line coming straight down, you can think of that as an equal sign, okay? And it's an augmented matrix because we're going to display the right hand side. So that is the matrix that you would generate from this system of equations. So let's talk about dimensions for a minute. The dimensions of a matrix are the row by column. And instead of writing the word by, we simply write an X. No, this does not mean to multiply, and no, this does not mean a variable. Okay? We simply just write our number of rows, an X, and then our number of columns. So for example, in this first one, I have 1, 2 rows, so I'm going to write 2, then an X, and I have 1, 2 columns, so a 2 by 2. Here I have 1, 2 rows, I'm going to write an X, and I only have 1 column, so it's a 2 by 1. Here in this last one I have 1, 2 rows, okay, and then 1, 2, 3, 4, 5 columns. So that's what we mean when we ask you to determine the dimensions of a matrix. It's simply the number of rows, x, the number of columns. Finally, in this video, I want to talk about how to translate an augmented matrix back into the system of equations. And for this, we're just going to walk backwards. Alright? So remember, our first column corresponded to x, our second column y, our third column z, and our last column corresponded to our right-hand side, or equals, right? So from there, I'm just going to read off. I can start down here. I've got 0x plus 0y, so I'm not going to really write those, minus 7z, so I'd have minus 7z. Then when I see the augmented part, I think equals, and then I write the right-hand side, 1. From the second row, I would have 0x, so I'm not going to write that, plus 5y, so I'd have 5y, plus 8z, augmented, so I think equals, and then the right hand side, -1. And from this first row, I have 3x plus y, because it's 1y, plus 4z, and then equals 0. And now from here you can see we're going to use this to start to solve the system of equations. From here I could very easily say that z was equal to -1/7. From there I could plug in z into this equation and solve for y. And once I had z and y, I can plug them both into the top equation and solve for x. We will demonstrate that more in the next video. So to review, we've taken a system of equations, written it as an augmented matrix. We've talked about the dimensions of a matrix, which is the number of rows by the number of columns. And finally, we just worked backwards. We took a matrix and wrote the corresponding system of equations.